What if the biggest discovery in the history of Mars has just been found, hidden inside a single rock? NASA's Perseverance rover has recently uncovered something extraordinary on the red planet. Strange patterns, mysterious minerals, and chemical traces that scientists say could be the strongest hint yet of ancient microbial life on Mars. But here's the shocking part. Scientists still cannot fully explain how these patterns formed without life. Could this rock be the first real evidence that Mars was once alive? Welcome to All About Mars Surface, your destination for the latest Mars discoveries and space mysteries. If you enjoy deep space documentaries and shocking scientific discoveries, make sure to subscribe, share this video, and drop your thoughts in the comments. Now, let's explore the mysterious Martian rock that could change everything we know about life in the universe. NASA recently announced that they have identified a possible sign of ancient life on Mars. The announcement came after a Martian rock examined by NASA's Perseverance rover appeared to display potential evidence of past microbial life. Scientists explained that after studying the findings for several months, they could not easily find another explanation for what they observed. The single rock that was discovered on Mars last year, called Chiava Falls, shows multiple features consistent with ancient microbial life and is truly unlike anything scientists have previously seen while searching for life. The discovery of Chiava Falls happened while the Perseverance rover was traveling through what was once an ancient Martian river valley known as Neretva Vallis. Water had flowed there billions of years ago, carrying sediment into a nearby lake located inside Jezero crater. At that time, Mars was at least occasionally temperate and possibly capable of supporting life. Eventually, the river dried out. Later, a rocky outcrop cracked and collapsed into the channel. There, millions of years later, the Perseverance rover fortunately discovered it. Chiava Falls measures roughly 3.2 by 2 by 2 feet and is covered with two fascinating kinds of markings: tiny dark dots called poppy seeds, about the size of ultrafine glitter, and larger lighter patches surrounded by darker edges known as leopard spots. When Perseverance examined the rock more closely, it also detected signs of organic compounds within it. These compounds are known as the chemical building blocks of life. Rocks displaying similar patterns also exist on Earth, and scientists believe they are often connected with fossilized records of microbes. The reason these spots may indicate life comes down to one key process: digestion. The leopard spots and poppy seed markings in Chiava Falls suggest chemical reactions that Martian microbes might once have used to obtain energy. Scientists had previously predicted that if life ever existed on the red planet, it could leave behind patterns like these. As we know, all life requires energy to survive. Some organisms gather energy from sunlight the way plants do through photosynthesis. Others obtain energy from chemical reactions between compounds. This works because every chemical compound contains a certain amount of energy that holds its bonds together. If a microbe can convert one chemical into another whose bonds require less energy, it can capture the difference in energy for itself. In the case of Chiava Falls, microbes might have converted organic compounds into lower energy chemicals such as water and carbon dioxide. Importantly, this process would involve removing electrons from the organic molecules and transferring them to iron atoms within the rock. The leopard spots and poppy seeds appear to record this process. Both the poppy seeds and the dark rims around the spots are made of a mineral called vivianite, which would form when iron atoms in Chiava Falls receive those electrons. Perseverance detected organic compounds in the same general areas of the rock where these reactions appear to have occurred. When iron in rocks like Chiava Falls gains electrons, its color changes from rust red to a pale tin shade. The centers of the leopard spots appear pale because they are places where these reactions completed their process, consuming the red iron that was available. Inside these pale areas, Perseverance also found another mineral known as gragite. This is where the story becomes more complex, but also more exciting for the possibility of life. Gragite can only form if a substance called sulfide is present. It is uncertain whether Chiava Falls originally contained large amounts of sulfide, but it does contain sulfate. Just as microbes can gain energy by transferring electrons from organic compounds to iron, They can also obtain some energy by transferring electrons to sulfate. Combined with the pale form of iron in the rock, this process could produce sulfide. That means Chiava Falls may contain evidence of not just one, but two different chemical reactions that microbes could use to generate energy. What may have happened long ago is that microbes gathered in areas of Chiava Falls where organic material was most concentrated and began consuming it by transferring electrons to iron in the rock. Where this occurred only slightly, it created the small dark vivianite poppy seeds. Where it happened extensively, the reaction spread outward, turning the surrounding rock pale tan. In the centers of these spots, the microbes eventually ran out of iron to accept electrons, so they may have switched to gaining energy by transferring electrons to sulfate, which ultimately formed gragite. This process would create pale centers of gragite surrounded by dark rings of vivianite, exactly the pattern observed in the leopard spots. There is even more evidence. Although Chiava Falls is the only known Martian rock with clear leopard spot patterns, Perseverance also found nearby rocks containing patches of vivianite and gragite. The paler these rocks appeared, the more organic compounds, vivianite and gragite, they tended to contain. This fits perfectly if the organic compounds served as fuel for reactions that turned the rocks pale and created vivianite and gragite, or if the organic material we see today is actually leftover traces of the microbes themselves. Scientists have proposed other explanations for Chiava Falls that do not involve life, but so far none fully explain the entire picture. The vivianite in the rock might possibly form on its own. Certain organic compounds can transfer electrons to iron even without life, producing vivianite naturally. However, it is still unclear whether the organic molecules in Chiava Falls belong to that category. Unfortunately, the Perseverance rover does not carry the large laboratory instruments that would allow scientists to determine this with certainty. However, forming gragite still requires sulfide. While certain organic processes can also produce sulfide without life, this is only known to occur at temperatures above 150 degrees Celsius. After extensive investigation, NASA scientists who studied Chiava Falls found no evidence that the organic compounds were ever heated to such extreme temperatures. Instead, they concluded that the spots appear more consistent with forming in a relatively cool and tempered environment. Another possible explanation is that the sulfide came from an external source. If hydrothermal or volcanic activity occurred near Chiava Falls, sulfide might have dissolved into groundwater and reached the rock that way. Interestingly, there was once an active volcano within about 50 kilometers of Chiava Falls. However, this volcano appears to be much younger than the rock itself, and there is no clear evidence that hydrothermal activity happened at the right time and location to explain the patterns seen in Chiava Falls. While it is still theoretically possible, it raises another problem. Even if sulfide entered the rock from outside, it would probably not produce the precise pattern observed today. External sulfide would more likely create irregular patches rather than sharply defined spots. It would also affect where gragite would be concentrated within each leopard spot. Instead of forming at the center, the sulfide would likely decrease as it moved deeper into the rock. For these reasons, the spotted patterns appear to be more naturally explained by microbes first using one energy source and then switching to another. Although this may sound like strong evidence for ancient Martian microbes, there is still much that scientists do not yet understand. Studying possible signs of past life in the rock will be a long and complex process, requiring further investigation by researchers around the world. Even though scientists currently have no better explanation for Chiava Falls than past microbial activity, that does not mean new explanations will not appear in the future. Researchers may eventually discover entirely unknown natural processes capable of producing a rock like Chiava Falls without life. Still, even if life did not create the gragite, the mineral would suggest that the environment once had conditions where microbes could have survived. Chiava Falls appears to contain all three essential ingredients for life: liquid water, an energy source, and organic molecules. NASA already has a plan to determine whether Chiava Falls truly holds evidence of ancient alien life by bringing the rock back to Earth. Currently, The Perseverance rover is carrying samples of Chiava Falls along with many other fascinating rock samples it has collected across Mars. This is part of the early stage of a major mission known as the Mars Sample Return Program, which aims to bring pieces of another planet back to Earth for the first time. The mission would involve sending another spacecraft to Mars, transferring Perseverance's samples onto it, and then launching a rocket from the Martian surface to send the samples home. Studying Chiava Falls samples in laboratories on Earth would allow scientists to determine far more precisely whether the rock contains evidence of ancient life. Researchers could identify exactly what types of organic compounds are present, whether they are molecules that can form vivianite naturally, substances that microbes could feed on, or even remnants of microbes themselves. Scientists could also search for chemical signatures created by biological digestion and examine whether the distribution of minerals inside the rock matches what would be expected from reactions driven by microbial activity. So although Chiava Falls may not yet be definitive proof of life on Mars, it could represent the strongest evidence so far that traces of ancient life may once have existed on the red planet.